Okay. So good morning, dear students. We will start with our today's session of electrical installation, maintenance, and testing. Uh, you can see the syllabus of the EMD subject, and we have started with this unit number 4A, which is a part of condition monitoring. I hope my voice is audible to you, and the screen is visible to you. Okay, so this part we have started, and we are interested for the transformer mainly, and one can say after doing the maintenance of a transformer, our substation or our switch yard can work effectively or can work satisfactory. Okay, yes. So that is the need of to do the condition monitoring of the transformer. So, in the last class, we have seen the failure modes or the failure causes of the transformer. So, basically, the failure modes are internal. Because of the internal faults, the transformer can be fail, or because of the external faults, the transformer can be failed. So, that is the reason why we are interested for these failure modes. Yes, and the main reason of this failure mode is about the insulation failure. So if one can ask you what is the important failure mode of the transformer is, so because of insulation failure, the transformer will get failed. So that is the important reason why the transformers are in the failed condition. After that, we have seen the condition monitoring of the oil. So we have seen the filtration and the purification processes, the plants which we have seen, which is under the category of this condition monitoring of oil as per IS international standard, and IC standards are also available. That is called as International Electrotechnical Commission. No doubt there will be the question will be asked for you. Explain the filtration methods for the transformer oil. So at that time, you have to write the name of that filtration or the purification system, and you have to try to explain that particular point. So that is an important concept from this second point. So this is nothing but related to the insulating oil, and we are interested for the condition monitoring of the transformer bushing. So this is the today's important part about our syllabus. Yes. So let me share my screen so that we will start with the introduction of what is meant by bushing and what is the purpose of bushing inside the transformer. Yes. So let me share my screen. Just a minute. Okay, so this is related to the transformer bushing. Yes, so might be you have seen the transformer which is available in our laboratory, in the high voltage laboratory. So the cage is provided, and in that cage, the transformer is placed inside it. Yes, so let's say this is our transformer. The transformer is obviously the oil filled transformer. Yes, and there are bushings are available for this transformer. Yes, now what is the purpose of this bushing? I told you earlier that the materials are divided into two types. The insulator is available, and one can say the conductor is available. The purpose of these two material is quite a different, and this concept is very useful for the electrical appliances or the electrical engineering. Yes. So the bushing is made up with the material called as insulator. Yes. And what is the purpose of this bushing? To provide a mechanical strength to the conductor. So from this transformer, the conductor is taken out like this. Yes. So this is the conductor 1 and this is the conductor 2 is taken out from this bushing, and to hold this conductor or to give the mechanical strength to this conductor, this transformer bushing is available. So what is a transformer bushing? It is an insulated device. Obviously, it is made with the insulator that allows an electrical conductor to pass safely through a grounded conducting barrier, such as the case of transformer or circuit breaker. So this is nothing but what is the meaning of bushing? Yes, bushing are made up of the material called as porcelain. Yes. So in many government exam, or you can say in many interviews, it will be asked for you what is the material to be used for making of bushing. So the answer is porcelain. Though other materials are possible. So there is a lot of research is going on in the field of bushing also. Today might we have seen the glass bushing also. So the glass bushings are also available for our transformer. Yes, so that is the another material which is possible to use for the bushing. We are interested for the figure of this particular bushing. So here you can see the bushing monitoring which we are interested. So obviously we have to test or we have to check the parameters for this bushing continuously. So that is called as word monitoring. Yes. So here you can see the head housing is available. So here is the head is available. Yes. So here is the outdoor insulator is available. So you can see the discs are available. After that, there is an active part, which is nothing but the conductor is available inside this. The mounting flange on which this head housing is provided. There is a ground sleeve is available. So obviously this is head and this is, you can say this is the ground. And where we are going to place this insulator with the material called as cast epoxy resin, and it is called as insulator. Yes. So this is based on IEEE PES July 26, 2010. So this picture is taken from this IEEE standard, and they have divided this typical bushing assembly in different parts. No doubt each component has its own function. Yes. So one can say without this outdoor insulator, we cannot hold or we cannot touch this particular part. Yes. So obviously it is made up with the insulator. Yes. And inside this there is a conductor is available like this. So this is the conductor is available inside this particular bushing. We are interested for the bushing monitoring. Yes. So according to double engineering client questionnaires, the leading cause, we are interested for the data. So this double engineering has collected the data, and they have found that the main cause of transformer failure is 35% because of the bushing only. Yes. So above 100 MVA, they have made the analysis, they have collected the data, and they found that of this transformer, the 35% bushing problems are observed. While most utilities periodically test bushings, there is a solid argument that periodic testing is not enough. We have to check continuously, not in terms of periodically, in terms of period of time. So inside the alternator, inside the induction motor maintenance, we have seen there can be the possibility of half yearly maintenance is possible. There can be the 15 days maintenance is available, or you can say can be a 7 days maintenance is available. But here is the case, this maintenance is not enough for the bushing. We have to check regularly. Today, tomorrow, in that way, we have to check regularly. Many companies rely on regularly scheduled maintenance testing. For those still relying on only on periodic testing, there are some compelling reasons to consider the continuous monitoring. So this continuous monitoring is very important for the case of bushing. Now, if you lose a bushing, so if our bushing is get failure, it is not necessarily true that the transformer will be damaged beyond repair, but following bushing problems are there. So it can say there is a typically some amount of damage. How much depends on how the bushing failed. A typical bushing failure occurs because the dielectric degrades. So we have seen the concept of dielectric also. Yes, it is nothing but the type of insulator. Yes. So if this dielectric or if this insulator fails, or if this dielectric degrades means losing its property, then one can say because of this degradation of this dielectric, our bushing will get failure. If no corrective action is taken, there will be eventually be internal arcing can be possible, which often led to violent failure. So if the dielectric degrades, so because of this dielectric degrades, the internal arcing can be possible, and if we are not taking the corrective action, it will lead to violent failures. If the bushing fails at air end means at head housing end, the substation crews have to contend with flying porcelain. तुम्हाला काय होतं असेल की ज्यावेळेस म्हणजे आपण म्हणतो की वी आर माउंटिंग द बुशिंग ऑन द ट्रान्सफॉर्मर. सो लेट्स से दिस इज द ट्रान्सफॉर्मर and we are pouring the ground sleeve at this point and the head sleeve is available at this point. So if this bushing fails, because of this bushing fails at air end, and there can be a flying porcelain, हे जे पोर्सिलिनचे तुकडे असतात ना हे उडू पण शकतात कदाचित तुटल्यामुळे किंवा फेल्युअर झाल्यामुळे. येस, अँड दे कॅन डॅमेज टू द सबस्टेशन क्रूज. जे सबस्टेशन मध्ये जे ऑपरेटर्स अवेलेबल आहेत ना त्यांना ते डॅमेज करू शकतात, which is a real danger to anyone in the substation. Further, those flying pieces of porcelain can damage the nearby equipment also. Most notably, other porcelain bushings. मग हे फ्लाइंग पोर्सेलिन मुळे दुसरे पोर्सेलिन जे चांगलं असेल त्याला सुद्धा डॅमेज होऊ शकतो, and because of this there can the crack is going to observe. So this is the main reason why the bushing is going to fail, because of the dielectric degrades. And what happens after the dielectric degrades? So flying porcelain can be available, or the pieces of flying porcelain can damage the other equipment. If the bushing fails at the oil end, so this is the condition at the top condition. Now we are interested for the bottom condition at the oil end. So here we are interested for the oil transformer. So if this side the bushing fails, then what will happen? The oil in the main tank may be contaminated. So there can be the you can say the contamination means there can be the possibility of foreign particles, or you can say impurity is going to add. The transformer coils may be damaged, and or the tank might rupture. So you can see because of the bushing fails at the oil end, what are the reasons is going to happen because of this bushing failure. And there is always concern about the fire. We know that this oil can catch the fire, and if the tank is getting failure, then it can catch the fire. The oil, oxygen and arcing are not a good mix. With the luck, the fire will be limited to the oil content in the bushing. In the worst case scenario, oil from the main tank will also ignite, leading to major fire and the complete loss of transformer. So this is the reason why we are interested for the bushing monitoring. Till now, what we have seen? We have seen the concept of bushing. We have seen the important condition monitoring of the transformer. Yes, and now we are interested for the bushing monitoring. How to do the bushing monitoring for our transformer? Yes, so let's go ahead. This is the picture, internal picture of, you can see the bushing is available. So these are the ground sleeves are available, and this is, you can say, the head of bushing is available. Yes. Now, where are these bushing used? So there will be a question will be asked for you, where we are using the bushing for our transformer. Obviously, the answer is about 23 kilovolt to 46 kilovolt bushing is used. Yes. So we have to give the strength of our conductor. So we are using the bushing for our transformer. Sometimes beyond this condition, 46 kilovolt, 69 kilovolt to 800 kilovolt, always we have to use the bushing. Here there is a probability sometimes, or if there is no availability of bushing is available, you can consider. But for this range of voltage, you have to use the bushing compulsorily. So here is a side view, and here is a top view of the particular bushing. Yes. Now here you can see, if we are interested for the measurement of the capacitance. So here is a lead 1, here is a ground lead, and here is a, you can say, the lead which is available inside the oil tank. Yes, we are interested to measure the capacitance between the top lead and the ground. So that is called as C1, and the ground and the lower lead, that is called as C2. Yes, obviously we know that when the capacitance of that lead is available, then and we are using the capacitance C1, C2 and C3 for this particular high voltage to our tap end, or our, you can say, the component which is available for our particular transformer. And this C4 capacitance is available between the tap and between the ground terminal. Let's say, one can say we are interested to calculate the C equivalent, capacitance equivalent. We know that when the capacitances are in series, then the C equivalent is available 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus 1 upon C4. Let's say if one or two insulation layer of bushing are damaged. असं समजा की एक किंवा दोन या इन्सुलेशन लेयर या बुशिंग्सच्या या काय झालंय, डॅमेज झालंय. नाउ वी नो दॅट इफ द बुशिंग्स insulation layer is damaged, the capacitance of that layer will be 0. That is, it is shorted. Particular range मधला जो capacitance असेल तो काय होईल, 0 होईल obviously. Now let's take the example. Let's say C1 value, C2 value, C3 values and C4 value are same, that is 2 farad. We are interested to find out the C equivalent. So 1 upon 2 plus 1 upon 2 plus 1 upon 2 plus 1 upon 2, it comes as 2. We are interested for the C equivalent. So the reciprocal of this becomes the 0.5 farad. Now let's say, because of the insulation layer of bushings are damaged, C1 is shorted. So if C1 is shorted, then we have to not consider this value because this value becomes 0. Now what will be the new value of C equivalent? C equivalent becomes 1 half plus 1 half plus 1 half. It comes as 1.5, and the reciprocal of this is comes as 0.66 farad. Now you can see there is a increase in the capacitance which is available at the previous value. So this is the first value which is available for C1, C2, C3 and C4. And if C1 is shorted, only C2, C3 and C4 are available in the circuit. The new capacitance will be more than your previous capacitance. Now it indicates, what it indicates? It indicates the fault. If we can measure the change in capacitance, obviously there is a change in capacitance, we can determine the fault in the insulation layer. From this test, the terminal, we can do a suitable measurement to determine the fault. It means what? It means if you are having the bushing with you have to measure the capacitance, you have to calculate the C equivalent for that particular bushing. And if that C equivalent is not going to match with your manual C equivalent, तुम्हाला कळत असेल की बुशिंग बरोबर सुद्धा एक काय मिळेल, तुम्हाला एक मॅन्युअल मिळेल. कंपनीने प्रोव्हाइड केलेलं एक मॅन्युअल असेल. त्या कंपनीच्या प्रोव्हाइड केलेल्या मॅन्युअल मध्ये ही सी इक्विव्हॅलंटची व्हॅल्यू ही त्यांनी फिक्स केलेली असेल, त्यांनी दिलेली असेल. आणि इफ यू आर गोइंग टू मेजर धिस capacitance value periodically, and if you are going to observe the change, it means it indicates the fault. Some insulation layer is get short circuited or it is get shorted. It means you have to replace that particular insulation layer. So this is called as condition monitoring of bushing by measurement of capacitance for the particular layer. I hope you understood this particular point. There will be sure question will be asked for you. Explain the condition monitoring of the bushing. At that time, you have to draw this figure. Yes, you have to write the explanation, or you have to write the you have to draw the equivalent circuit diagram for that particular bushing. Yes, you have to consider the example like 2 farad for each capacitance are same. You have to make sure that one capacitance can be shorted and the other three capacitances are in series with the circuit. So there is a change in capacitance and this indicates the fault. Yes. Now we are interested for the next point, that is called as the tap changer. This is the point which is obviously asked in the interview exam. Yes, the name indicates itself. The tap is provided which is for the changing purpose. A tap changer is a device which is fitted to a power transformers only. We are not going to observe the distribution transformer tap changer. We are going to observe in the substation or in the switchyard only the power transformers, and for the power transformers the tap changer is provided. Now what is the purpose of this tap changer? For the regulation of the output voltage to a required levels. Now you know that whenever we are interested for 11 kilovolt by 33 kilovolt step up transformer, yes, for this step up transformer, obviously this is the power transformer, and this power transformer, the tap changer is provided. Why? Because we have to regulate the output. We have to regulate this 33 kilovolt to a required levels. Now there are two types of tap changer. On a load tap changer and there can be off a load tap changer. So it is also called as OLTC, on a load tap changer. Where these are necessary? These are necessary in the regulating power transformers. Where we are using it? Used in electrical energy networks and industrial applications. So this is the need of OLTC inside the power transformer. तुम्हाला कळत असेल आता की पॉवर ट्रान्सफॉर्मर हा तुमचा कंपनी मधून येतो. येस, अँड यू हॅव टू यूज वन कंपोनंट दॅट इज कॉल्ड एज अ टॅप चेंजर फॉर दिस. येस. Now here you can see the taps are provided. So here you can see the different taps are provided. So this arrow indicates the selection of this particular tap. The tap changer alters. What it alters? It alters the turn ratios. तुम्हाला कळत असेल की आता की N1 आणि N2 जर चेंज केले मी तर काय होईल? The appropriate voltage corresponding this N1 and N2 is going to change of the transformer on the system by altering the number of turns in one winding of the appropriate transformer. Either I have to change the number of winding for primary, or either I have to change the number of winding for secondary. So then and then our voltage corresponding to particular winding is also changed. The tap changers offer variable control to keep the supply voltage within these limits. So there are two types, offload and onload. Onload is also called as online. Yes, so in many books they are using the word online load changer, online tap changer. Yes. However, since the offload tap changer causes the interruption in the supply, hence onload tap changers are more preferred in the today's power system. तुम्हाला कळत असेल की ऑनलोड म्हणजे काय किंवा ऑनलाईन म्हणजे काय. चालू ऍप्लिकेशन मध्ये वी हॅव टू चेंज दिस पर्टिक्युलर टॅप, बट फॉर द केस ऑफ ऑफलोड वी हॅव टू आयसोलेट द ट्रान्सफॉर्मर अँड वी हॅव टू चेंज दिस पर्टिक्युलर टॅप. इट मीन्स व्हॉट? देअर कॅन बी द इंटरप्शन कॅन बी पॉसिबल. तुम्हाला तो ट्रान्सफॉर्मर हा आयसोलेट करावा लागेल सप्लाय पासून. यू हॅव टू चेंज द टॅप अँड यू हॅव टू अगेन रिस्टोर दॅट पॉवर ट्रान्सफॉर्मर. So that is called as a offload application of the tap changer. But inside the power system, inside the today's power system, we are preferring the onload tap changer. तुम्हाला कळत असेल की we are interested for the reliability. Reliability means what? Continuous power supply. We are interested. Hence, we are using the online components, onload components. Yes. So this is the reason why we are using the onload tap changer only. There will question will be asked for you for your interview why we are preferring onload tap changer. Yes, so at that time you have to explain it properly. Now we are interested for the transformation ratio. We know that inside the electrical machine you have studied the concept of transformer. So for the transformer, there is a concept called as transformation ratio. It is indicated with the letter K. Yes. So this K factor, it is nothing but the ratio of V1 by V2 is equal to N1 by N2. So if you are interested to calculate this V2, so V2 can be N2 by N1 into V1. So by rearranging the term, we will get this equation. From the above equation, by altering the turns ratio to a suitable values, the secondary voltage can be adjusted to desired level. Let's say N1 is 2750 and N2 is 100. मला काय असेल आता की ट्रान्सफॉर्मर म्हटल्यावर मला टर्न्स लागतील. येस. सो लेट्स से दिस इज द प्रायमरी which is a 2750 number of turns are available, and for the secondary I am using only 100 turns. So let's say these are the only 100 turns are available. So no doubt this is a step down transformer. We have to find out the transformation ratio for this. So 2750 divided by 100, which comes as 27.5. So this is the factor of this transformation ratio. Now, why we have to choose this turns ratio? Let's say primary voltage is nothing but V1. V1 is 11 kilovolt. So for the 11 kilovolt, we have to use the secondary voltage as 400 volt. Why? Because we have to maintain the transformation ratio as 27.5, which is same at this. It means if we are placing 11 kilovolt for primary voltage, obviously the secondary voltage must be 400 volt, so as to keep the transformation ratio same as per the turns ratio. Here there is a chart is prepared based on the different readings of the turns and based on the different readings of the voltages. So here you can see 11 kilovolt by 400 volt, which gives you the transformation ratio 27.5. And if you are interested for the turns ratio, you have to divide primary turns divided by secondary turns. So no doubt this transformation ratio and turns ratio are same to give or to use the appropriate voltage range. Now we are interested for the application or the working of this on-load tap changer. Here you can see each tap corresponds to different transformation ratio. For initial installation, we need to choose a suitable tap as per our voltage levels. The tap changer provides, so this is the limit to provide the voltage change, 5 to 20% voltage range for voltage regulation. असं नाहीये ट्रान्सफॉर्मर मध्ये किंवा टॅप चेंजर मध्ये की 230 व्होल्ट तुम्हाला ऍप्लिकेबल आहे एखाद्या कंपोनंट साठी आणि तुमचं व्होल्टेज हे 5 व्होल्ट झालं आहे आणि तुम्हाला म्हणायचंय की आय हॅव टू यूज द ऑनलोड टॅप चेंजर अँड आय हॅव टू यूज दिस 5 व्होल्ट टू 230 व्होल्ट. इट इज नॉट पॉसिबल. येस, देयर इज अ कंडिशन at which or up to which you can change the voltage level. So 230 जर तुम्ही 5% केलं किंवा 230 तुम्ही 20% केलं, it comes near around 200 volt. So 200 volt झालं असेल तुमचं सिस्टीमचं व्होल्टेज, so you can boost this voltage with the help of this on-load tap changer. Yes, so this is the application of the on-load tap changer. We are interested for the different transformer tap changer positions and the related voltage levels in the primary and transformation ratios for the secondary. Here you can see there is a positions is available for OLTC 1, 2, 3, 4, 5, 6 up to 15. The positioning is available. The high voltage winding, we are interested for voltage and current. So let's say the voltage which is available for high voltage winding is 35,360. At that time, the current can be drawn by this particular high voltage winding can be 244.9 ampere. Obviously, low voltage winding is available, which carries an amount of voltage 7,100 volt, and current which carries 1,220. We know that when there is a high voltage, the current is available in the low amount, and when there is a low voltage available, current is available in high amount. No doubt the power drawn by this transformer is the same, that is 15,000 watt, VA. We are interested for the transformation ratio. So here you can see for one position, the transformation ratio can be 4.98. We are interested to choose the particular position for particular voltage. If our voltage level drops to 28,753, to boost this voltage level to 35,360, we have to choose the 15 number tap. So it corresponds to the transformation ratio 4.05. Now we are interested for the working. So here you can see the on-load tap changer working, or there are contacts are available for this particular on-load tap changer. Yes. So here you can see the internal connections are explained here. Yes. Now we are interested for the tap selector. Here you can see the arrow is provided. Yes. This arrow is going to choose particular tap according to the particular voltage range. Obviously there is a fixed contact is available, and obviously there is a moving contact is available, and because of this particular position of this tap changer, this position is going to change from this to this, from this to this, and from this to this. Yes, so here there is a position is available. You can see 1 2 3 4 positions are available for changing this moving contact. An on-load tap changer has three major steps. What is the first? Tap selector. It selects the appropriate tap. Fixed contact. This contact holds a fixed position. And moving contact. This contact moves to open, close the appropriate taps. Now what you have to do? You have to select the moving contact. Let's say the moving contact is connected to this position. Let me use the eraser so that you can understand this concept clearly. Now, if we are interested for this moving contact, the amount of current is going to enter from this to this, this to this, here to here, and here. If we are choosing the particular tap like this, so if this arrow is connected to this, so the amount of current is going to flow from this wire to this selector, to this, to here, and from here. Yes. At that time, you have to move this contact at this point to this point. Yes. Let's say there are different positions are available for this. Yes. So this is the switching sequence of tap selector. So here we have to choose first tap selector. So from here, let's say this is position 1. If you want to move the position 1 to position 2, so at that time we have to remove this arrow from this position 1 and we have to connect this arrow to position 2. At that time the moving contact is connected to one position only. So this is the one position. Yes. Now if we are interested for the switching sequence, so how to make the switching? Obviously we need the feedback. असं नाही की तुम्ही टॅप चेंजर घेतला आणि तुम्ही तो मूव्ह करत बसले. सो तुम्हाला कळत असेल की एखादी सिस्टीम जेव्हा आपण ऑपरेट करतो किंवा इफ वी आर ऑपरेटिंग वन सिस्टीम, then obviously we need the feedback, and based on the feedback, if the voltage level is less than your corresponding voltage, then we have to change the position. So here the feedback, the suitable tap is selected, figure A to C. Yes. After the tap is selected, the moving contact moves and it also closes both the taps for a while. It moves further and finally completely opens to earlier tap and closes to next tap, figure D to I. मला काय दिसलं आता की फिगर पोझिशन 2 ला तुम्ही काय केलाय, टॅप सिलेक्ट केला आहे. येस. आता हा तुमचं टॅप सिलेक्टर झालं सिलेक्शन. आता यू हॅव टू सिलेक्ट द मूव्हिंग कॉन्टॅक्ट फ्रॉम दिस पोझिशन टू दिस, from this to this, from this to this, and from this to this, and at that time the current will enter to this side. Yes. So this is the switching sequence of the tap selector. Now there is obviously current limiting resistors are used inside the changing of the position of the moving contact. Now, what is the purpose of this current limiting resistor? The name indicates itself. We have to limit the current. Let's say the moving contact closes the two taps for a while during the tap changing, due to which a circulating current starts to flow. तिथे काय तयार होईल? एक circulating current हा flow होईल. To limit this circulating current, we have to use these current limiting resistors. So here I have mentioned these currents need to be minimized. We have to control this current. Hence, for limiting this current, resistor or reactors are used. The moving contact is operated by charged spring tension. हे जे मूव्हिंग कॉन्टॅक्ट्स आहेत ना, हे चार्ज स्प्रिंग टेन्शनने ऑपरेट करावे लागतात. ज्यावेळेस आपण स्विचयार्ड मध्ये किंवा सबस्टेशन मध्ये ऍप्लिकेशन करतो त्यावेळेस इट कम्प्लीट्स द प्रोसेस विदिन 30 to 70 मिलीसेकंड. द स्प्रिंग इज चार्ज बाय मोटर ड्राइव्स. ती स्प्रिंग ही हाताने चार्ज करायची गरज नाहीये. देयर इज अ मोटर इज अवेलेबल टू चार्ज द स्प्रिंग. While opening and closing the contacts, sparks are produced due to arising recovery voltage. The contacts are kept in oil or SF6 gas. So both these are the insulating medium. SF6 means sulfur hexafluoride gas, which works as insulation medium as well as arc quenching medium. तुम्हाला कळत असेल की ज्यावेळेस बोथ दोन कॉन्टॅक्ट्स हे एकमेकांपासून दूर जातील त्यावेळेस तिथे काय तयार होईल? एक स्पार्क तयार होईल. Yes, and if we want to quench this arc, then we have to use the insulating medium like oil or SF6. Here you can see the physical construction of the tap changer. तुम्हाला दिसत असेल आता की टॅप चेंजर मध्ये हे जे टॅप सिलेक्टर आहे हे या साइडला बसवले त्यांनी. Yes, and here the oil compartment is used to quench the arc. Yes, जो स्पार्क तयार होईल ना त्या स्पार्कला क्वेंच करण्यासाठी we have to use the oil compartment. Yes, so this is the MDU is available. The unit is available here. Yes, and inside this part is going to fix. What is a motor drive unit? MDU. This unit has got the motor driver and other necessary control. The motor charges the spring to rapidly perform the switching. तुम्हाला सांगितलं होतं की जी स्प्रिंग चार्ज करण्यासाठी we are using the motor and that need the motor drive unit. Power is transferred via shaft and gear mechanism. We need the oil compartment. So this diverter switch or oil compartment we need. What is going to happen in this? This has a diverter switch which has a moving and fixed contact. Diverter switch तुम्हाला इथे दाखवतो मी. This is called as a diverter switch. आपण डायव्हर्ट करतो ना एनर्जी किंवा पॉवर. Hence it is called as a diverter switch. And here we are selecting the tap. Now, for this diverter switch, which has a moving and fixed contacts, it is filled with oil or SF6 gas to avoid a sparking and quenching during opening and closing of the contacts. The tap selector, it has the different tap combinations as specified by the customer requirements and different standards. हे टॅप सिलेक्टर असे बनवले जातात की कस्टमरची जशी रिक्वायरमेंट असेल किंवा कस्टमरला जसं व्होल्टेज त्याला कंट्रोल करायचं असेल बट बियॉन्ड रेंज ऑफ 5 to 20% ओनली और बेस्ड ऑन द स्टँडर्ड्स अवेलेबल. Yes, so this is called as the on-load tap changer. So here you can see the on-load tap changer design is placed. So this is called the diverter switch. Diverter switch. So limiting resistors I have used over here. Current limiting resistors. First, I have to select the tap, and then I have to use the diverter switch. And we know that the circulating current is going to produce. To limit the circulating current, I have to use the current limiting resistors. So this is called as a switching principle of this tap selector. Here, the real picture I have used. Here you can see the tap position indicator which shows 0 to 5 position, 5th number position, this position. They have given the high voltage tap voltages, so tap numbers are provided. Here you can see the percentage change. Here you can see the high voltage values, and here you can see the connections which is going to make inside the transformer. Here you can see you have to use the 5th number tap. So 20 and 15 are connected. and this is the position of the manual tap changer. हे जे आहेत ते डिजिटल आहेत, digital tap position indicator, and here you can see the manual position indicator is used. Yes, no doubt inside the industry, inside the substation, previously manuals are going to use. Nowadays we are using a digital tap position indicator to show the particular tap. Yes, now we will see one video which explains you the working of this condition monitoring of particular you can say the on-load tap changer. So just a minute, let me share my screen for this video. So this is the video. Okay, just a minute. I hope the screen is visible to you. Yes. Is it visible? Video is visible? Yes. Okay. Now we will see one animation. Based on this animation, your concept of on-load tap changer is going to clear. Yes. Here you can see the power station is situated. Our substation is situated at here, and our load is situated at here. So load is you can say the custom, you can say household load, and this is the industrial load. Now you can see the network's voltage level drops due to higher energy demand. तुम्हाला काय दिसेल आता की 230 किंवा 440 व्होल्ट जर रिक्वायरमेंट असेल, and because of extra load, this voltage level is going to drop. Yes. So at that time we have to use the on-load tap changer for adjusting the voltage level. You can see over here, this is the power transformer is there, and this power transformer are coupled with the tap changer. So here is a tap changer. So here you can see the reference value they have set as 100 volt. Yes. Now you can see the voltage is going to drop. And what is the reference? 100. What is the actual voltage? 98.54. Yes. And at that time you have to make your 100 volt as the requirement. And for this you have to change this position. So you can see initially the 9 position is available, and we have to compensate this voltage for 100 volt. We have to shift the position from 9 to 10. Now how this 9 to 10 is going to happen? Let's see. So I hope you understood the concept of the onload tab changer. Yes. So if you have understood the concept of onload tab changer, you have to write yes. If you have not understood the concept, then you can write the no as well. I will try to explain in other better way. Yes. Uh, yes. Okay. So thank you for attending the class. At 11:30, you are having the next class. And if you have any doubt related to this concept or this subject, then you can ask me anytime.